Welcome back to the deep dive. Today we're looking at a fascinating contrast from one manufacturer, NTI, focusing on two products that really define the absolute extremes of professional video connectivity.
They really do. It's a great deep dive into distance versus, data density.
Exactly. So on one side, you have the question, how far can we possibly push a signal?
And on the other, how much data can we cram into one space as efficiently as possible? Our mission is to sort of explore what happens when you really prioritize one of those physical challenges over the other.
Okay, let's unpack this. We'll start with what we can call the distance specialist. This is an extender built for professional broadcast video, the 3G SDI standard.
Right, and for anyone who doesn't live and breathe this stuff, 3G SDI is basically the gold standard for sending uncompressed high-def video and broadcast.
What's really remarkable here, though, is that it operates using a single, tiny LC fiber optic strand.
Just one strand.
Yeah.
And if you use the standard multi-mode fiber, you're already getting a really respectable 1,640 feet. That's about 500 meters.
Which is great for a campus, a large building, that kind of thing. But if you swap that out for the ultra-thin single-mode 9-micron cable, well, the whole game changes.
The distance just explodes. It really defies what most people think of as cabling limits. You jump from half a kilometer to 12.4 miles.
20 kilometers.
20 kilometers, that's roughly the distance of a marathon. You're sending a perfect high-definition signal over a cable that's as thin as a hair.
Yeah, connecting a stadium to a control room downtown, or linking two facilities across an entire city. And the quality holds up HDTV up to 1080p at 60 hertz.
Right, along with all the professional broadcast standards you'd expect.
But I want to focus on the control side of it. It has a local loop out so you can see the source locally, but it also has this unidirectional RS-485 control. What's the deal with that?
That control channel is absolutely vital. The video flows one way out, but this RS-485 control flows back from the receiver.
Ah, so it's not just a one-way street.
Not at all. This lets you send remote commands, think pan, tilt, zoom for a camera, or adjusting a sensor all the way back to the source 12 miles away. It turns a simple video pipeline into a practical two-way production link.
I see. And the receiver outputs to two displays at the same time.
That's right, simultaneously.
Okay, so we've conquered 12 miles of distance. Now, let's pivot completely. If the distance specialist fights the physics of light over long fiber, our next product, this KVM switch, it fights the physics of cramming data down a short copper wire.
Exactly. We shift to what you could call the local data monster. It's a 4-port KVM switch, letting one user control up to 4 Ultra HD computers.
And when we say maximum data, the sources specify resolutions up to 4K. 4096 by 2160 at 60 hertz. But here's the key detail I saw. YUV 4.4.4 color depth. Why is that so critical?
That is the absolute gold standard for professional creative work. 4.4.4 means zero color compression, no artifacts.
So for graphic design, CAD, color grading?
Anything where color accuracy is non-negotiable. And to achieve that, you need serious, sustained bandwidth. We're talking 18 gigabits per second. It's just a massive load for a desktop device.
But here's the efficiency trick, the part that really stood out to me. The switch handles this intense 4K load. It supports HDR advanced audio, yet it requires no external power supply.
Yeah.
How is that even physically possible?
It's just incredible engineering efficiency. It's designed to draw all its power from the attached computers through the USB bus. It consumes, at most, 6 watts.
There's no power bricks, a cleaner desk, more reliability.
Exactly, and you still get 2 dedicated USB ports for your keyboard and mouse, plus 2 separate transparent USB 2.0 ports for, printers or touch screens.
So to sum this up, we've looked at two products. One pushes professional video nearly 13 miles across town. The other quietly aggregates the maximum amount of 4K data right on your desk with zero power from the wall.
They perfectly illustrate the entire spectrum of connectivity challenges. The fiber extender solves a logistical problem of separation, and the KVM solves a physical problem of local bandwidth limitation.
And that data density issue leaves us with this final provocative thought for you. The KVM switch supports that beautiful 4K 60 Hz signal over standard cables, but only up to about 15 feet. However, if you want to push that exact same 4K signal just a bit further, say to 100 feet with an active cable, the maximum resolution suddenly drops from 60 Hz down to 30 Hz. What does that stark trade-off, that halving of the frame rate, reveal about the fundamental physical challenge of moving high-resolution information?